Hello friends, in today's session we are going to see some more interesting parts related to our chapter, that is modules. Okay, so we will proceed further now. The service-based keywords. Modules support services with the use of keywords, provides, uses and with. In the last session we introduced what is service and what is service provider. Okay, so what is service? Service is like a interface or abstract definition, and service provider is actual implementation. Okay, so one service can be a generalized thing that can be used of any number of service providers specifically. Okay, so these are some service based keywords that will be used by modules, like provides, uses and with. A module specifies that it provides a service with a provide statement. Okay, if the particular module is providing a service, it is telling you that it is providing through a use of provide statement. Module indicates that it requires service with uses statement. If module is requiring a service, then it is using a uses statement or uses keyword. And specific type of service provider is declared by with keyword. Okay, so if a module is providing a service, it will use the provides keyword. If it is using a service, it will use the uses keyword, and a specific type of service provider is declared by with keyword. When used together, they enable you to specify a module that provides a service, module that meets a service, and the specific implementation of that particular service. The module system ensures that the service and service providers are available and will be found. Okay, so when they are uses, these three keywords, uses, provide and with, it ensure you that the service and service providers are available and will be found over here. So what is the generalized syntax? Provide service type with implementation types. So if any module is using this generalized syntax, what is its meaning? It is providing a service type with implementation types, specific type of service provider. Okay, specific implementation of that service provider. Service type specifies the type of service which is open and interface, although abstract classes are also used. Okay, service type is a type of the service which is open and interface. So it is just an declaration of a service, not actual implementation. And also abstract classes are also used in this case as a service type. A comma separated list of implementation types is used by implementation types. Therefore, to provide a service, the module indicates both the name of the service and in implementation. Okay, to be understandable by user, okay, or a programmer, which is telling you that it is providing a service by service type and which is implementing that particular service using the implementation type. And more than one implementation type will be specified by a comma separated list. So, generalized syntax of uses keyword, uses service type. In this case, any particular module is using a service type. Here, service type specifies the type of service required. Okay. Then module-based service example. So, to demonstrate the use of services with the use of example, what we will do now, we will add a service to modular application example that we have been evolving since the last session. We will begin with the first version of application shown at the start of this chapter, that is modules. And we will add two new modules in that particular first version of application. First is called user functions. It will define interfaces that support functions that perform binary operations in which each argument is integer and result is an integer. Okay, so we will add two new modules in that particular first version to understand the module based service example. First module we will add that is called as user function. In user function, we will define interfaces that support functions that perform binary operations in which each argument is an integer and the result is an also integer. The second module is called user functions IMP. It contains concrete implementations of the interfaces. Okay. First is only interfaces. One module is only having interfaces, and second module in user functions implementation, user functions IMP will have complete or concrete implementation of that particular interface. So now we will begin with creating the necessary source directory. Under that source directory, add directory called user functions and user functions IMP. Okay. So user functions is our first module and user functions IMP is our implementation is our second module. Under user functions, add the subdirectory also called as user function. In that, add the subdirectory called binary functions. In that, we will have that will perform the binary operation in which each argument integer and result is also integer. Okay. Beginning with app source, we will have this tree like app source, user functions, and binary functions. Then in the next module, user functions IMP, add the subdirectory called user functions IMP with the same name. Under that directory, add subdirectory binary functions implementation. Thus, beginning with app source, we will have like app source, user functions IMP, and binary functions implementation. This example expands the original version of application we have seen in the at the beginning of this chapter by providing support for functions beyond those built into the application. Okay. So this example will expand the original version that we have created by providing support for functions beyond those built into the application. So we will add more functions into that application. The simple mathematical function class supplies three built-in functions: each factor, least common factor, and greatest common factor. It would be possible to add more functions to this class. Doing so requires modifying and recompiling the same application, and we don't want to do so. So by implementing services, it becomes possible to plug in new functions at runtime without modifying the original application, and that is what this example will do. The service supplies functions that take two integer arguments and return an integer result. Other types of functions can be supported if additional interfaces are provided. Okay. Other type of functions can be supported if additional interfaces are provided. But binary support for binary integer function is sufficient for our purposes to add new things into our original application and keep the source code size for the example manageable. Okay. So this example is only for the sake of understanding purpose. Okay. So we can add as many interfaces as needed, but if we will add them, our size will become larger. So we will keep it as small as possible. Okay, and then our code will be also manageable. Okay. So next, the service interfaces. Two service-related interfaces are required. One specifies the form of action and the other specifies form of provider of that action. Actually, we will require two service-related interfaces. One interface specifies the form of action and the other specifies the form of provider of that action. Both goes in binary functions directory and both are in the user functions.binary functions package. The first called binary function declares the form of binary function. So service related interfaces, first is binary function declares the form of binary function. This interface defines a function that takes two arguments and returns an integer result. Thus, it can describe any binary operation on two integers that returns an integer. Okay. package user functions dot binary functions, public interface binary function. This we are going to add. Obtain the name of the function, public string get name. Okay, so it is only getting the name and it is the abstract. Okay, so it is not having the definition. This is the function to perform. It will be provided by specific implementation. Public integer functions a, b. Okay, two integer parameters, return result as an integer. Binary function declares form of an object that can implement a binary integer function. Okay, this binary function interface. Okay, this binary function is the name of interface, declares the form of object that can implement a binary integer function with having two integers and return one result. This is specified by a function method. Name of the function is obtainable from getName. GetName will tell you the name of the function. Public string getName. The name will be used to determine what type of function is implemented. Okay. Name will be used to determine what type of function. By using that getName, we will understand what type of function is implemented. This interface is implemented by a class that supplies a binary function. Okay. So this interface will be implemented by a particular class that supplies the binary function. Okay. So if any particular class like my class implement binary function, that must implement that function, FUNC. The second interface declares the form of service provider. Okay, then it is called as binary function provider. This interface defines a form of service provider that obtains binary functions, instances, or objects. Package user functions dot binary functions, import user functions dot binary functions dot binary function. Public interface binary function provider, public binary function get. Okay, so you will only have the getting the object of binary function interface. Okay, we will have the function object by using get method. Binary function provider declares only one method, that is get, which is used to obtain object of the binary function. This interface must be implemented by a class that wants to provide object of binary function. Okay, so binary function is provider interface must be implemented by any class that wants to provide instances or object of binary function. The implementation classes. Two concrete implementation of binary functions are supported. First is absolute plus, which returns the sum of the absolute values of its argument provided in the bracket. And second is absolute minus, which returns the result of subtracting the absolute value of the second argument from the absolute value of the first argument. Okay, so two detailed implementations are provided. First is to obtain the sum. Second is used to obtain the difference or minus. These are provided by the classes absolute plus provider and as well as absolute minus provider. The source code for these classes must be stored in the binary functions implementation directory, because we are implementing over there and they are all part of the user functions implementation dot binary functions implementation package. Now, code for absolute plus is shown here. Absolute plus provides concrete implementation or detailed function of binary function interface. And how it is implemented? Absolute of two values. Okay, addition of absolute of A and absolute of B. Package user functions implementation dot binary functions implementation. Okay, in that we are importing user functions dot binary functions dot binary function package. Okay, public class absolute plus implements binary function. So when it is implementing this interface, which are the methods it has to implement? First is get name and second is function. Okay, public string Get name will return the name of function as absolute plus, and integer function will give you the absolute addition of two absolute values, mat.absolute A, mat.absolute B. Absolute plus implements function such that it returns the result of adding absolute values of A, B. Notice that get name will give the name as absolute plus, and it identifies or gives the name of the function. Now we will see absolute minus class. Absolute minus provides complete implementation or detailed description of absolute A minus absolute B. Package user functions implementation, dot binary functions implementation, import user functions dot binary function, and absolute minus implements binary function. Get name will give you absolute minus and implement the absolute minus as mat.absolute A minus mat.absolute B. Function is implemented to return the difference between absolute values of A, B, and get name will give you name like a absolute minus. To obtain the object of absolute plus provider is used that will give the object of absolute binary function interface. Okay, so it will give you object of absolute plus, and it implements the binary function provider like below. This is the provider for absolute plus function. Package user functions implementation dot binary functions implementation. Import user functions dot binary functions. Public class absolute plus provider implements binary functions provider and absolute plus object. Public binary function get return new absolute plus. Okay. So get will give you the object of binary function interface. Okay. So which class we want here? Absolute plus. Okay. So this is the class here, absolute plus implement binary function. And when we are implementing this provider interface, it will return you the binary function instance object. That is, whichever class is implementing this binary function interface. So in this case, absolute plus is implementing this binary function interface, and absolute minus is also implementing the binary function interface. So if we are implementing this binary functions provider, absolute plus provider implements binary function provider, this get will give you the object of absolute plus. The get method simply returns the new absolute plus object. This provider is very simple. Some service provider will be much more complex. So if you will understand the basics of this service providers, you will understand the complexity also. The provider for absolute minus is called as absolute minus provider. It's like this: package user functions implementation dot binary functions implementation, import user functions dot binary functions. Public class absolute minus provider implements binary function provider. Public binary function get return new absolute minus. Okay. And this get method in this class absolute minus provider will give you the object of absolute minus. Okay, like new class name semicolon. Then the module definition files. Two module definition files are required. First is for user functions module. Module user functions export user functions dot binary functions to the outer module. Okay, so binary functions is exported over here. This code must be obtained in a module info.java file that is in the user functions module directory. Okay, it exports user functions dot binary functions package. This package is the package that defines binary function and binary function provider interfaces. Okay, so binary functions package is a package that defines both binary function interface and also binary function provider interface. The second module info.java we will having defines module that contains the implementation. Okay, it goes in the user functions implementation module directly. Your module user functions implementation requires user functions. Okay, so it requires this. It provides user functions dot binary functions function provider with user functions implementation dot binary function implementation dot with is for specific type of implementation by comma separated we have used in the syntax. So require that one module is dependent upon another module. Provide, it is providing a service. Which service is providing? User functions dot binary function provider with, these are the implementation type. Two implementations are done over here. One is the addition of two numbers, absolute of two numbers a and b, and second is difference between two numbers, absolute minus provider. User functions implementation dot binary functions implementation dot absolute minus provider. This model requires user functions because that is where binary function and binary function provider are contained. Okay. Why it is requiring user functions module? Because where that is where binary function and binary function provider both interfaces are there, and those interfaces are needed by the implementation over here. The module provides binary function provider with two implementation types. One class is absolute plus provider and second is absolute minus provider. Okay, demonstrate the service provider in my mod app demo. To demonstrate the use, now we will see the main method of my mod app demo is expanded to use absolute plus and absolute minus. Okay, so we will now modify the public static void main method of my mod app demo, and that will use absolute plus and absolute minus. It does so by loading them at runtime by use of service loader dot load. Okay, so updated code we will see. We are not doing anything in the original code. We are not doing any change in the original code. We are only modifying. And we are only providing a service as a service provider as a plugin. Okay, so original code will remain intact. Only runtime, the use of service loader will be there by using load. Here is the updated code. A module-based application that demonstrates services and service providers. Okay. Package abstract.mymodappdemo. Import java.util.serviceloader. Okay. Add functions, simple mathematical functions. Import user function dot binary function dot star. Okay. In the public static, built-in functions as before, is factor, least common factor, and greatest common factor. Those will be as it is here. Those built-in functions were there from this simple mathematical functions. If simple mathematical function is factor, 2 is completely divisible by 10. 10 is completely divisible by 2. 2 is a factor of 10. Smallest common factor between 35 and 105 is 35 using LCM, and largest common factor is found out by GCM. Now, use service-based user-defined operation. Get a service loader for binary functions. How you will get it? Service loader in that binary function provider. Okay, that will be service provider. LDR is equal to service loader dot load. And what it will load? It will load the binary function provider dot class. Okay, at runtime. Binary function, binary operation null. Find the provider for absolute plus and obtain the function. For binary function provider, BPF LDR. So what is LDR? It is a service loader. From this service loader, for each while for loop we are using, from this service loader, we are getting the binary function provider object. And we are iterating through this one by one. Okay. So if it is getting, if bfp.get name, it is absolute plus, then binary function object, we are getting binary OP is equal to bfp.get. So it will give you the object of absolute plus, and then we are breaking. Okay. And if it is not equal to null, result of absolute plus is binary OP. So this will be the object of absolute plus. So how it will operate? Absolute plus object dot function, where we have implemented 12 and minus 4. So absolute of 12 plus absolute of minus 4 will be our result. Else absolute plus function not found. So absolute plus implementation is done now. Now again we will make it as null. Now find the provider for absolute minus and obtain the function. So for each type for loop BFP colon LDR, if BFP.get name equals absolute minus, we will get the object of class absolute minus in binary operation and then break. So it will have the object of absolute minus. If it is not null, result of absolute minus, binary operation dot function 12 and minus 4, absolute of 12 minus absolute of minus 4. Otherwise, absolute minus function not found. Now we will see how a service is loaded and executed by the preceding code. First, a service loader for services of type binary function provider is created by this LDR object. Service loader for binary function provider is loaded using binary function provider dot class. The type parameter to service loader is binary function provider. This is also the type used in the call to load. Okay, because it is providing you the class at runtime. This means that providers that implement this interface will be found. Okay, at runtime. Thus, after this statement execute, binary function provider classes in the module will be available through LDR to iterate in the for style for loop. In this case, both absolute plus provider and absolute minus provider will be available. Next, a reference of type binary function or called binary OP is declared and initialized to null. Okay. Reference of type binary function called binary OP, which will have the object of absolute plus and minus, is declared and initialized to null. It will be used to refer to an implementation that supplies the specific type of binary function, whether it is absolute plus or whether it is absolute minus. The following loop searches LDR for one that has the absolute plus name. Find the provider for absolute plus and obtain the function. Okay. So if it is equals absolute plus FBFP.get break. Here for each style for loop iterates through LDR. Inside the loop, the name of the function supplied by the provider is J. Okay. If it is absolute plus, it is sent to binary OP by calling the provider's get method. If the function is found, it is executed. The result of absolute plus, like if it is not null, absolute of 12 plus absolute of minus 4. Because binary OP refers to an instance of absolute plus or object of absolute plus, call to function performs absolute of value addition. Similar sequence is used to find execute absolute minus. Because my node demo now uses binary function provider, its module definition file must include a user statement that specifies this fact. Okay. So this my mod app demo is an abstract module and it should give you the uses. Uses is it is using the binary function provider, service provider. You must change it like this. Module info.java for abstract. Module definition for main application module, public static void main. It now uses binary function provider. Module abstract requires app functions, requires user functions, and now uses binary function provider. Uses user functions dot binary functions provider. Okay. So this way we have completed some theory concepts related to our chapter module. In the next session, we will complete the theory part completely and then we will move forward for the practical part. So till then, you can enjoy the module processing. You can understand how modules are working and you can also practice at your home. Okay. More you will practice, more you will understand. And if you are understanding, you don't need to remember it. Okay. It will be automatically remembered. And most important thing is you will enjoy the process. Okay. So meet you in the next session. We'll with the next theory part. Thank you so much.